a lead rubber bearing in your project. Could you explain some of the reasons why you had used that, and were any of them particular to the height of the building?
Yes, of course, the height of the building was a very important factor to the choice of what kind of isolator we wanted. In fact, the pendulum system, we thought of that in the first way, but we discarded it because of, we thought that in the case that some uplift were occurred for any reason, the consequences of that impact of the superstructure impacting the isolator will be greater in that case than if we use some rubber bearings.
I have a question and a comment to Chunhe. Henry, the second speaker. The question is that I noticed that you used some dampers, the 50 viscous dampers to your case study. So my question is that how much seismic reduction you obtained when using the dampers compared with without any dampers? That's my question.
Yeah, that's a good question. To tell you the truth, in reality, the client decided not to use damping. We did study, but they think this will add some cost, also which will make the construction period longer. So that's why they don't use it. But in another side, we can see if we use damper, we can reduce more mass and stiffness, which will save cost. I think that this is why we are here to promote to use damper in the design, because this industry needs some experience, need expert to do more study on damping. Is it dependable? Is it it's durable? A lot of issues we need to know. So I think this is very important in the future for us to promote for using of damping. Thank you.
Yes, actually, I have a comment. Yes, you mentioned the cost efficient is most important for structural design. So I agree with your point. But the normal damper for super tall buildings, the purpose is energy dissipation. But for normal dampers for super buildings, is relatively small compared to the huge mass of tall buildings. So the other approach is to increase the ductility of the structures of super tall buildings. We can employ the energy dissipation from some structural components. Probably that's even more efficient. I mean, energy dissipation efficient.
Yeah.
That's my comment.
Yeah, I agree with you. But in another hand, if we use supplementary damping, which will give us more confidence on the damping ratio we used in the design, which is 4%, seems quite high compared with the CTBUH recommendation.
Yes, for Henry Lee again, you say that you have sized up something at 60 damper, 60 number of damper that can achieve the 4% that specified by the code. How you actually do that actually? Why come out with 60 number of damper?
You mean our damping ratio?
Yes, you're saying that you're trying to achieve the damping ratio of 4%, right? And then you size up 60 number of damper.
Yeah, actually we don't do that study. Yeah, actually if we use 60 damper, and we can do analysis to get equivalent damping ratio. which may be more than 4% normally, I think. Yeah, but we need to do more study on that.
Yeah, thank you. It's good to hear that you guys have an update for that CTBUH tall building guideline. My question is that, so you also mentioned about the different guidelines in United States. You have tall building initial published by Pierre, and we have LOA tall building design guide by the LOA Tall Building Council. I was there, it was in May in this year, so they had 2014 version. So many different guidelines in the United States, and here you have another update for the CTBUH. So is there way to go to a uniform code for the tall building design guideline? As there's no leading position for the different guidelines.
My opinion would be that any type of guidelines that you're going to produce, the model, at least on the West Coast, Ron, you can interrupt me if I misspeak here, but I think on the West Coast, the LA Tall Building Guidelines were actually published by a group of experts who were called together to try to, come up with formulate a set of rules. And as a result, the guidelines were seen as being useful, and the municipality actually brought them up and adopted them as law. And I think the same model kind of happened in San Francisco as well, didn't it, Ron? Something like that. The idea would be that, I could tell you that the aversion that at least I've witnessed with my work with iStructD is that if a document has something on it that says Los Angeles or San Francisco, that's a very U.S.-centric, it was published for a certain audience, it has a negative impact on having people pick it up and read it and use it. And the idea, I think, with CTBUH and why I think they're in a unique position to be able to do something a little bit different is because they do have more of an international group that's dealing with the publication. So I'd strongly, I would really love to have somebody from internationally involved in this effort.
So that the CTBUH is more or less cover the international concept, not only limited to the United States.
Right.
And
Right.
that's concept. Yeah, I know that San Francisco has same guideline as, I think it's called SB 86 or something. Well,
Yeah, it's a bulletin.
bulletin, yeah, it's just bulletin. And it's more limited for the local jurisdiction. I know if you design the local buildings, you have to follow their guideline, which is accepted by the city and local. So I don't know, besides this CTBUH, do you think in United States in the future, are they going to publish something like AC 41 or AC 7 just to specifically talk about the tall building design? Yeah, that's.
Well, I don't know. LA and San Francisco can't even agree, so I'm not sure how the rest is. I mean, the idea would be that what we would try to do is put out a best model. I mean, one of the things that struck me with my work in London was that, they're trying to implement the Eurocode all over the place, and so they were looking at really what type of design guidance is given out internationally for work. Probably and there's not a lot of information, and so the idea would be, I think that it's really appealing to have an international group do something like this. And my own personal opinion, others may have different opinions, is if the design guidance is good, people will pick it up and adopt it and start using it. But that's the reason why it has to be published as something that's just recommendations and alternate recommendations that could be incorporated as another check. Maybe at some point they'll be picked up completely, but they aren't adopted by any international group right now. So the idea would be put the guidelines out there and see if people start using them.
This is kind of a two-part question, but it's related, and I would like to start with a quick question to Mr. Sukamta, and I hope I got that right. In my experience, limited experience in Indonesia, is that, and it's great to see the work you're doing there, is that there's been a bit of pushback and resistance from the local approving community regarding adopting performance-based design and using technology like base isolation. I just wanted to know if you could elaborate on your experience with that, with the approval process and the projects you've been doing.
Yes, in Jakarta, there's an expert panel review team, and every building taller than 8 stories has to go through the review of this team. And if you put forward a new method like the PBSD or the seismic isolation system, it will take longer than normal. And sometimes I can say it's a bit painful process. But if you want to progress, then you have to go through that.
Well, it's good to see we've got people like yourself to go through the pain for the rest of us. The second part of this question is for you, John, and I think it's great to see the work you're proposing. Have you think there's any role or any thought about perhaps some type of outreach program to educate regulators or to just inform them and enlighten them about this approach and the advantages it brings to public safety so it does become more widely adopted to reduce having to experiment on projects in different municipalities, which we all do if you work internationally?
Yeah, I would hope that the guidelines being published could be read that way. And, you know, like if you read the peer document, there's several different audiences that is published for and it's written for. And part of that is written for reviewers, part of it is written for, there's several different audiences. And I think that the idea with our own guidelines would be, we'd be talking about a protocol for the process as well. The process of having expert panel review or peer review for performance-based design is very well developed in China, not nearly as well developed in the U.S. I mean, in the U.S. it's more of a recent procedure, but the idea is that it's kind of interesting that that procedure is developed in 2 different parts of the world, but it's starting to become very, very similar, and they're both borrowing from each other, like certain aspects of design, performance-based design, the protocol and the process. And my hope would be that this would be a guideline that would actually answer those questions, and someone could pick it up and not necessarily get so involved in reading the nonlinear analysis portions of it and the modeling, but also looking at how the protocol of process would work and how it should work.
Do you see there's any role with the CTBUH in lobbying for regulators to adopt this on behalf of the industry?
I mean, one of the first things that one of the reasons why I got involved in this really was because one of the recommendations that came out of the Earthquake Engineering Advisory Group was publish an international guidelines for using performance-based design as an alternate method. So this kind of means I don't have to do that. If we can do this through another international agency, my first idea would be presenting this to IStructD, as an option. And I think that people would see that as being very, very appealing because, like I could say, it's not, sometimes I think the U.S. publications are actually, they aren't looked at as closely because they are viewed as being so U.S.-centric. And I think there's an aversion to that. But if you have an international group where a document has been peer-reviewed internationally, people are going to respond a lot more positively to it. And so I think there's a possibility of doing that.
In my experience in my country, if, for example, this PBSD method is adopted in prescriptive code like the ASCE 7, then it's easier to be received by the expert panel team.
Yeah, and we didn't even coordinate this, but Mario, didn't you say that in Chile they're looking at?
Exactly. Currently in Chile, the local seismic code is being reviewed, and a new chapter of performance-based design is included that is based on the Los Angeles code. We all hope that this inclusion will be a boost to those nonlinear techniques.
When I think of performance-based design, I always think that you actually have to, measure the performance. Is there anything like that in the, or will there be anything like that in the update as well?
Well, right now, I mean, the way that the method, if you read through it, based on the updated Los Angeles code for alternate design, they just call it alternate design method. It's really, there's two different types of elements where design work is done. It's either force controlled or deformation controlled. And even in that document, they borrow from, there's recognized in the system for if you're going to put a building or a structure through a maximum credible earthquake, there'll be pieces that will actually deform and energy will be dissipated in them. And those elements like are actually reviewed by another criteria that they reference, which usually is ASC 41, because it's the only document out there that sets limits on immediate occupancy, collapse prevention, and then life safety. Well, life safety and collapse prevention. But even if you go to the ASC 41 meetings, and I'm a member of ASC 41, nobody really knows what life safety exactly is. It's kind of a factor of safety on collapse prevention. And that's how it's been, framed. And the idea would be to, maybe more useful definitions between immediate occupancy and collapse prevention could be developed. And maybe that could lead to more research. Ron's been involved with some work in San Francisco where they've actually done some full-scale modeling on a system where they're testing how much deformation capability a slab has, right, in a system. And so, it could lead to more useful research also done in the field for different types of systems that would be more cost-effective and easier to construct.
When I actually mean measuring the performance, I more focus on like monitoring systems. The CTBUH released a research report saying that this is one of the main research items that need to be addressed. And when in the research field, when people talk about performance-based engineering, they look at actual measurements of the buildings, such as the Burj Khalifa,
right,
and link those details back into the standards. And I know that some of the standards of the ASCE have like outdated values, and if you want to improve, which is the goal of performance-based engineering, you actually need to measure the performance and then continue the improvement in this field.
Well, in the latest Los Angeles code too, I mean, there is a requirement for monitoring, a certain minimum level of stations. And I know that your building in San Francisco, Ron, MK's building in San Francisco is actually, monitors. It's instrumented, and it even got some measurements that were small in the latest earthquake that was significant in the San Francisco area.
Actually, in China, there's quite detailed measurement for performance on different levels, such as frequent earthquake, intermediate earthquake, and rare earthquake. Different level of force with different measurement on different members, such as column, shear wall, beam, and damper. For damper, it's energy dissipation. It will be treated differently. So it's quite detailed, specified in China code already.
When I was looking at the program, was what portions of the current guidelines are kind of confusing or require some clarification? And I don't know if somebody in the audience or others on the panel want to speak to that, but even from my perspective, like reading the current guidelines, they just are kind of broad topic discussion.
One thing I noticed is not quite clear to me is that critical damping in the modeling in current guideline in the CTBUH is not conformed to other guidelines. I think it was specified 4% or something. I think another is how do you use critical damping to modify the disaster spectrum is not clarified in that guideline too. I was trying to find the equation to justify disaster spectrum for the long period. Yes, once you have different critical period, you can justify spectrum. That's not quite clearly in the codes too.
Yeah, and I think another area that probably needs a little bit of work is Appendix B. I mean, Kanokpat talks about it in the application, the Mahanakan Tower, but I think it probably just needs a little bit of expansion to clarify one or two areas. And I think some of the benchmarking of it actually being applied might help in terms of clarifying some of the procedures within it.
And one important issue is on the minimum wage shear. If it's not written in the codes, some authorities still require us to put the minimum wage shear, which is way too big.
Because your name difficult to pronounce. In your presentation, you had compared the pros and cons for the timing of the connection of Oregon. And the conclusion is that connection at early stage is better than later stage. However, based on my experience, it's better to connect the Oregon at later stage after the differential settlement had been settled down. And I just want to know any special measure or consideration had been taken in your design calculation to consider the additional force or the stress concentration caused by the early connection of the Oregon. Thank you.
We have been a long discussion about that, about the Oregon connection time. And not only that, we also discussed about should it be the steel structure or should it be RC structure. And we discussed among the designer and the production team on site. In Thailand, the construct methodology for the concrete is very popular, and not a lot of the structure in Thailand that do the outrigger in steel structures. The cost of the construction for the concrete structure is very, very cheap, and compared to the other countries, and also the labor cost is cheaper. So we prefer to go for the concrete outriggers. And by using the concrete outriggers, the difficulties for the connection of the outrigger after we cast the slab above the outrigger floors is very difficult, and the program schedule of the project is very tight. The facade is 6 floors below the casted slab floors, so the facade is very close to the construction floor. So we cannot delay the outrigger too long because the facade will close first, and also the outrigger that we have in our projects is not to resist the lateral load. On level 19 to 20, the columns start to kink in, so we need the outrigger to connect right away to stabilize this kink column. And on level 35, the second outriggers, we will have new columns starting from those outrigger floors. So the outrigger walls behave not just only for the lateral resisting structure, but also the framing part for the gravity load as well. And like I explained in my presentation, that the differential axial shortening between the column and the core is very excessive in this project. I didn't go into detail about that because today we concentrate on the CTBUH seismic guideline. But If we don't have any outriggers, the floor will tilt around L over 20, which is around 25 centimeter or 250 mil for the distance of 5 meter from the core. So it's very huge amount of the floor tilt, and it's not acceptable in terms of the serviceability. So we need to use the outrigger to take some load back to the core and reduce the column shortening between the column and the core. So it's quite complicated problem that we at the end we decide to connect them earlier, not for the lateral resisting system, but for the gravity, for the axial shortening.
I have a question for the third speaker from Chile. And you use the isolation to reduce seismic effects for tall buildings. It is true, it will get quite big benefits by using isolation techniques. But for tall buildings, besides the seismic effects, we have to consider the wind effect. So my question is that what's a wind effect, or have you conduct comparison on the wind effect with using the isolation and without isolation? Is isolation, base isolation, create the positive effects or negative effects on the wind effect on the tall buildings?
A limit of the height of the building that you could isolate is in fact determined by the existence of isolation tension, tension forces on the isolation. So if your building is taller, that could be a problem, and it's a problem that you don't have in small buildings. If your building is taller, you have a greater overturning moments, and then you could have some tension forces on isolator. And the other limit for isolate a structure, a tall structure, is that you could effectively decouple the periods of the fixed base solution with the isolated solution.